Hello to all of you and welcome back to my SP2 channel. This video is the first lecture of our chapter 3. We're going to be looking at general properties of aqueous solution. I have a kind of introduction to solution, solvent, and solute. We're going to be looking at the two terms electrolytes and non-electrolytes. I do have a little bit to tell you about how we can dissolve this stuff in water, and we also have a practice at the end, just like always. Okay, so starting by kind of introduction. So there are a few terms that we need to introduce them here. I'm going to start by solution. So a solution is the homogeneous mixture of two or possibly more substances, right? And in our solution, the particles of solute are typically uniformly distributed throughout the solvent, right? And that's what we call that homogeneous. And the mixture appears as a single phase. Could be liquid, could be gas, or even a solid. The example that I have for you is salt water, which is a solution of table salt in water. So I'm going to talk about the solute and solvent, starting by solvent here. The solvent is the substance in our solution that is typically present in the largest amount or largest quantity. It's pretty much the medium in which the solute dissolves. In our example, water is going to be our solvent, right? And the solute is typically the substance that is dissolved in the solvent. Usually we have that presented in a smaller quantity when you compare that with your solvent, right? And in the example of salt water, the table salt, right, is going to be our solute. Okay, now we're going to be looking at electrolytes and non-electrolytes. These two are very common terms, right, in our chemistry. Let's get started by the electrolytes. So these are the substances that dissolve in water or potentially another solvent in order to produce ions, right? So because we have cations and anions, they can actually conduct electricity, right? Now, to what degree they dissociate, we call them differently, okay? So if I have a complete dissociation, like 100% dissociation for them, we call them as strong electrolytes. But if I have less than 100%, we can say partial dissociation, we call them weak electrolytes. So for example, sodium chloride is an example of a strong electrolyte. When you add that in water, it is going to completely dissociate, right? But if I have something like hydrofluoric acid, that is a weak acid, right? So these are the ones that are going to dissociate partially in water, okay? Then we have the non-electrolytes, and these are the substances that when you dissolve them in water, or again, potentially another solvent, they do not produce any ions, right? So because we don't have any cations, we don't have any anions, they're not going to be, they're not going to be able to conduct electricity, right? So they are going to stay as a neutral molecule without any ionization. For example, if I have something like sugar, right, could be, sucrose or like fructose, you can dissolve them in water, right? But they're not going to produce any ions. Another example is ethanol, which is a very common alcohol, right? Again, you can dissolve it in water for sure, but there won't be any, ionization. There won't be any dissociation for that. Okay? Cool. Okay, so now let's talk about the dissolution in water. So the process of dissolving something in water is called dissolution, right? And there are going to be a few steps that I need to consider that to understand the process completely. The first thing is when you add your ionic compound in water, they are going to dissociate into their cations and anions, right? So having this positive negative charges here is a key. Then you can think about the structure of water molecule. The oxygen part of the molecule, right, is what we call the electron rich, which is partially negatively charged. And that is going to be interested in having interaction with your cations of your solute, right? And then the hydrogen portion of water, which is kind of positively charged, is more interested in having interaction with the anions of the solute. So this kind of interaction is going to create a very stabilized, interaction overall, which is known as solvation, right? So let me show you using picture. So this box that you see, where we have, green and purple balls, are presenting our sodium chloride. So the green balls are your chloride, and the purple balls are sodium. Okay, so you're adding your sodium chloride in water, and this is my H2O, which is water. So what happened here is your chloride that are negatively charged are going to stay pretty close to the hydrogen portions of water because they are positively charged. That's how we can stabilize our negative charge, right? Kind of electrostatic interaction here. And then for sodium, which is positively charged, they're going to stay close to the oxygen portion of water, right? This is known as solvation. As you can see, they are creating layers or the shells of water around these cations and anions, right? Okay, cool, cool. Now, let's take a look at this practice. The question here is, which are the following groups of substances contain only strong electrolytes? So looking at option A, I have potassium bromide, which is an ionic compound. So this one is a strong electrolyte. But then I have an SO2, which is not an ionic compound, right? So this is not going to be a strong electrolyte. So you can cross out choice A, right? And by the way, calcium chloride is a strong electrolyte. But because we have SO2, I need to cross it out. Then we have choice B. HCl is a strong acid, so that's a good one. But then we have ammonia, right? NH3. This guy is not a strong electrolyte. It's actually a weak base. We'll talk about the acid and bases in our future lectures. Okay, stay tuned for that. And then sodium hydroxide is a strong base, right? But just because I have NH3, you can cross that choice B. Now, finally, we have choice C. And yes, this guy must be the answer because if I have sodium nitrate, hydrochloric acid, or even rubidium sulfate, they all are going to be quite a strong electrolyte. They all are going to 100% dissociate in water. Okay, cool, cool. Thank you very much for watching this video. And yes, you know what to do, right? You just need to, give me a thumbs up if you like it. You can share it with your friends and let me know if you have any comments or any questions, right? I'm going to be definitely reading these comments very carefully. Take care of yourself, and I'm going to see you soon in the next video. Bye bye for now.